All right, guys, let's all get back at it. Hopefully you did your stretches and all that good stuff. And hopefully you're back to do some math life. And hopefully you're pumped and ready to do some of this here. All right, so a lot of this you've already done. What exactly does arc cosine half mean? All it means is cosine of what angle equals a half. And there is an infinite amount of answers. It goes on forever. Because remember, it's just a wave. You get half over and over and over and over and over again, especially in the unit circle. You get half here and up there. So this angle gives you half. This angle gives you half. So does this angle. If I go clockwise, that's a negative, of course. So all those angles give you x value of half. And if you go another 2 pi, you're still in the same location. Like if you go another 2 pi from this right here. So if you do, if you go, that's still going to give you half. So all those answers give you half, guys. And if you remember, so what did we say last time? So we said, I think well, you know what? I think what we said, I'll just follow from here. So what did we say last time? We figured out these formulas. We actually figured out those formulas without them telling us. We figured them out with logic. Hopefully you remember. I don't remember what notes it was. I should have written down the note number, but I apologize, guys. Next time I'll do a better job and I'll write down the notes that we got them from. So what did we say? We said plus minus arc cosine of half. And then we said, well, the principal branch, or the very first one that we get, is pi over 3, because that's 60 degrees. So then we said plus minus, you know what? I think I said plus minus arc cosine half plus 2 pi n. That's what I think I said. And then arc cosine a half is pi over 3. So pi over 3 plus 2 pi n. And then this is going to give us all the answers, where n is an integer. N is a whole number. You can also say integer. It can be negative if you go clockwise, and it can be positive if you go counterclockwise. And that's it, guys. That's all. So then I put a little statement here. Just don't become a robot. There's a reason why the plus minus is in the front. And remember why that is. Because if we're in degree mode, cosine of 60 degrees, I meant to put a 0 there. Cosine of 60 degrees is going to be a positive half. But so is cosine of negative 60 degrees. That is also a positive half. So that's why we have the plus minus, because this one's a plus and this one's a minus when we're doing the inverse of it. So hopefully that makes sense. So now we have our first example. It's very simple. It might even be the same example we did way back then. It says find the first positive values of arc cosine. Yes, I know you can do it with the unit circle and just remembering the first one that it hits and then keep going clockwise. But I want to use this formula. So I'm going to use this guy. So this guy says ARC cosine 1/2, because well, 0.5 is a half. And it tells me to do plus minus. And you can still call this, I know it's confusing, this is still arc cosine. I prefer to call this inverse cosine, but if you want to call it arc cosine, that is perfectly okay, guys. So there it is, inverse cosine of half plus 2 pi n, just like that formula says. And then I'm going to put equals. So I'm going to put 1 for the positive and 1 for the negative. So here's the positive one. So I'm going to call this equation 1, arc cosine of half plus 2 pi n. And I'm going to call this equation 2 over here. Negative arc cosine a half plus 2 pi n. Now there's a reason why they call one positive, one negative. If you have a CAS, and you type this, just that right there in brackets, into a calculator, the calculator is going to give you pi over 6. No matter how many times, no matter how many times you type it into the calculator, it's going to give you pi over 6. Does that make sense to everyone? It's not going to give you the negative one. It's just going to give you that one positive. Rubio, does it make sense? Yeah. All right. Virtual class, are you guys okay?
Yes.
Okay.
Yes.
Oh, you guys sound sad, guys. That makes me, I don't know who it was, but they were like, yes. Like it was really sad. Guys, don't be sad. We're doing math here. So there it is, guys. Pi over 6 plus 2 pi n. That's equation number 1. And it's not pi over 6. Oh, dummy. How come you guys didn't correct me? Pi over what, guys? Pi over, not pi over 6, pi over
3.
Pi over 3. Yeah, not pi over 1, silly. At pi, it's cosine is -1. So equation 2, our cosine of half, that's going to be negative. I wanted to do it in blue. Negative pi over 3. The negative just comes from that one. And then plus 2 pi n. So from that, now look, it says the first 5 positive. And I know you could have done it with a unit circle and just kept on going revolution. Here are my answers. So, and I guess I should choose a neutral color. So let me choose the neutral color of black here. So the first positive number I hit is pi over 3. This one's coming from equation 1. The second one that I hit is going to be in quadrant 4, and you get it from negative pi over 3 plus 2 pi n. That's going to be 5 pi over 3. Chavez, how'd you do that? Like this, guys. Well, one, I know the unit circle, but if you were to go negative pi over 3 plus 2 pi, well, if I want the common denominator of 3, that put a 3 there, put a 6 there. 6 divided by 3 is 2 pi. Negative pi plus 6 pi, that's 5 pi over 3, see? So that one goes right there. So that comes from number 2. The third one's going to come from equation 1. So I'm going to just rewrite this as 6 pi over 3. You can put the n here on the side. 6 pi plus pi is 7 pi. That's another answer. Another answer is a 5 pi over 3 plus 6 pi over 3. So let's see, 5 plus 6, that's 11 pi over 3. That's from equation 2. 1, 2, 3, 4, so I need one more. So 7 plus 6, 6 is 12, so that's 13. So 13 pi over 3. And that came from equation 1. And there it is, guys. And all of those should work. If I type in cosine of any of these, I better get a half. And I think you do. So let's go ahead and try it out really quick with Desmos. And you don't have to, but I'm just trying it out just so you guys can see. So let's go to Desmos. Desmos. And I don't need a graphing calculator. I just need a calculator. So scientific. And I'm in radian mode, so click on radian. So there it is, radian mode. And I'm just going to type in, was it one of the main functions? Yeah, cosine. And what did I say, pi over 3? Well, everyone knows that one. So there it is, half. Let's try the other one. Cosine, oh, clear. Enter. Cosine, and then we said what, 5 pi over 3? 5 pi over 3. Yep. And then what else did we say? Cosine, what's the next one that we put in there, guys? 7 pi over 3. And then look at that, another half. And then what's the next one we put? 11 pi over 3. And check it out, another half. And what's the next one? 13? 13 pi over 3. And was that the last one? And there it is, guys. Check it out. All of them worked. Yay. So now let's go back. Are we understanding everything that we're doing so far, guys?
So you got the last two numbers, so you got the 11 pi and the 13 pi by adding 6 pi to the 5 pi and 7 pi, right? Just to make sure.
Yeah, that's fine. You can. That's a method that I do. I got the 11 pi over 3 and the 13 pi over 3 from equation 2 and equation 1 by just increasing the n there, which really, remember, these are solutions coming from those equations. So I just keep adding 2 pi to the previous answers that I had. And then there it is in order from smallest to largest. Did I answer your question, Ms. Cruz? I think it was Cruz. I'm not sure.
Yes.
Okay. And it was Cruz, right?
Yes.
Okay. Sorry, miss. All right. Sounded like you said a bad enough. Find the first 5 positive values of our cosine of negative 0.3. All right. It's not a perfect radian, so we're just going to do it with our formula. And yes, I know you can do it the way Delta Math does it, find your reference angle, and then all that good stuff. But I'm just going to use my formula, guys. Arc cos, that's an S, of negative 0.3 equals plus minus, and this is still arc cos, but I like to call that inverse cosine. Inverse cosine of negative 0.3 plus 2 pi n, because it repeats every 2 pi. So here's equation 1. So I'm just going to type this into my calculator, and I'm going to see what it is. And it's not a perfect radian, so we're not going to, so don't expect a perfect radian. So here we go. It's not, what I mean by perfect radian, it's not going to have pi in it, guys. Clear all. I go to function, I go to inverse cosine, and I just type in negative 0.3, and I push enter. And there it is. You want at least 3 digits after the decimal. If you want to write more, that's perfectly fine. So that's what I'm going to write, guys. So 1.875. Oh, there's a fly here, guys. I'm trying to shoo it away. So here we go. So I'm going to write, I put a equation 1 there. There's my general equation. Plus minus 1.875. Oh, short-term memory. Was that the number? It was, right? Okay, plus 2 pi n. Equation 1. Equation 1 is a positive one. 1.875 plus 2 pi n. And I'm going to write equation 2. I'm not going to color code it this time, guys. I'm just going to write it. And it's negative 1.875 plus 2 pi n. What did they want? They wanted the first 5 positive values. So here we go. So the very first one is 1.875 because that's the first positive value, comma. The next one is coming from this one. So it's coming from equation 1. So I'm going to add 2 pi to that. I have a calculator here on my side. Well, I guess I'll show it to you for now, and then after that, we'll just do it randomly on the side. So here we go. Here is my Desmos, and I'm going to take this 1.875, and I'm just going to add 2 pi to it. Plus, oh, I guess I can't do it like that. I guess I got to go up. You know what? I'm going to call that A. A equals. There we go. And I'm just going to go A plus 2 pi. And there it is, 8.158. If you want to round it, that's fine. 8.159. Oh, but that's I did that for the positive one. All right, I'm not gonna leave yet. Let's do it for the negative one. So I'm gonna put negative A in the front. And there it is, right? 4.407 or 408. So here we go. Let me go back. Okay, so the negative 1.875 plus 2 pi gives us 4.408. And then the 1.875 plus 2 pi gave us 8.158. And then this is equation 2. This is from equation 1. And then go back to equation 2 so you can get it from the 4.408. So the 4.408 plus 2 pi. And we got 10.691. Is that 5 values? 1, 2, 3, 4, one more. So then go back to equation 1, the 8.158, and add 2 pi to it. And I got 14.441. And there it is, guys. And there it is. I wrote down where those equations are coming from. Any questions so far, guys? Yeah. Yes. Well, when I added 2 pi, it gave me this one, plus 2 pi. And then when I added 2 pi to that one, it gave me this one. And then where did I get the 4.408? I got it from negative 1.875 plus 2 pi. Negative 1.875 plus 2 pi. And then when I added 2 pi, it gave me that one, plus 2 pi. Do you see what I did? And there it is in order. Virtual class, you guys doing all right?
Yes.
All right, you guys sounded happy on that one, guys. See, that's what I want to hear. Happy math. See, math brings out the best in all of us. I bet you some of you guys just want to be in math all day long. Okay. I can already see some eyes rolling probably virtually, right? All right. All right, future medical doctors. If any of you guys ever become future medical doctors and you guys become my physician or my doctor, hook it up with the good stuff. Like, give me the best medical care possible. No, I'm just messing with you guys. I don't know. I don't even know if I want to live that long. Like, why don't, okay. Well, I mean, I don't know. How old are you guys? Like 15? Oh, well, I don't need any medical attention anytime soon. Like, I hope that to stay away from hospitals for the next, I don't know, 30 years, 40 years at least. I haven't gotten a physical in a while, so I probably should go get checked out, see if everything's all right. All right. Let's see where we're at. Oh, thank you, miss. Let's see. Let's see where we are at. Are we really there? All right. Yeah, we're really here. I thought I had more columns in here. All right, so it says solve with a calculator, and then put right here, put or Desmos. 7 cosine 2 pi over 13 x minus 4 plus 9 equals 5 on the interval, -7 to 27. So let's do that. I'm going to type this guy in that I just circled. I'm going to type that dude into y1, and I'm going to type this dude into y2, and I'm going to see where they what? I thought someone was going to say it, but no one said it. I'm going to see where they intersect, guys. Right, Rubio? Yeah, where they intersect, Rubio. Come on, miss. All right, Rubio says that you guys should have gotten it really fast, but she's really mad that you guys did not. So shame on you guys. No, she didn't say that, guys. All right, so there it is. So I'm going to go to Desmos, and I have short-term memory, so you guys are going to have to hook me up with Y1. So, I mean, I don't know if I really have short-term memory, so I probably shouldn't be saying stuff like that. But I noticed that if I don't sleep much, my memory tends to not be very good. So here's graphing calculator, and yeah, just like I told you guys that I was going to forget the equation, all I remember is y. So y equals something. So y equals, and I want to say the number was 7, but I'm not sure. 7? All right, and then I remember it was a cosine, and then parenthesis, and then what? 2 pi 13, and then open another parenthesis, x minus 4, close, close, plus 9. All right, and then I'm opening up another equation, and then I'm going to type in y equals, and what did it equal? 5. And then it said a domain to look between x equals what and what? -7 all the way to 20 something. 27. So I'm going to go all the way to 27, guys. So boom, right there. So you can see the grid. Oh, I can't see negative. Well, I can barely see -7. You can see the grid. It's counting by 1. And here are the points that you want. So you guys write them down, and then I'll write them down after you guys write them down. So I want this point where they intersect. So type -4.492. That's a value. So write x equals -4.492. You do not have to write the 5. You just the -4.492, comma, and then let's see what the other value is. -0.508. So write -0.508, comma, let's see the next one here. 8.508, comma, 12.492. And then next, or comma, 21.508. And last but not least, I wonder where that common phrase comes. Last but not least, or anyways, 25.492. Chavez. There was a bird in the cafeteria? What'd you guys do to the little birdie?
I don't know how he like came in and then he was running into the window.
Oh, poor bird. There was a bird in the cafeteria today, guys. Hopefully it lived, but Rubio was saying that it was slamming into the windows. So, oh yeah, but imagine you slamming into a window, it would hurt. So poor bird. So hopefully the bird's all right. But all right, guys. What answers did we get? So hook me up with what we got going left to right. Negative. It's real quick before we proceed, guys. Anytime you write a decimal, like if it's like 0.508, I get a lot of students that just give me this, and that's fine. I'm not going to count it wrong. I think physicists and mathematicians both agree on this one situation here. Put the 0 in the front to signify 0.508. If you don't do it, it's not a big deal. We're not going to take off points, but you might have an old school professor who's like, put the 0 in the front. So anyway, so yeah. All right, continue. Ooh, we got a lot of answers. Okay. There's something that we have to recognize about this. So I'll write all this stuff down, guys, and then I want you to just focus for like 30 seconds. I want to see if we're really learning. I want you guys to recognize, I hope that we can recognize this, that this is our B value, and they're being nice to us. They put a 2 pi in the front, so that means 2 pi over period. So from that, we can tell that the period is 13. Does everyone see that? Okay. I want you to recognize, let's see, which one's easy to see. Look at this. What is the difference between 8 and 21? 8, 18, 19, 20, 21.
13.
Wow, look at that, guys. What is the difference between 12 and 25?
13.
13. There's a reason why that number keeps popping up. By the way, it comes up again, right? Look, the difference between these two right there, negative 4.492 and 8.508, that's also 13. And the difference between negative 0.508 and 12.492, that's also 13. The reason why it keeps popping out is because the period is 13. So let's look at that graph again. And I want you guys to see. Well, yes, you can see that the peak here is at 4, and then I have another peak here, 15, 16, 17, is at 17, and the difference between 4 and 17 is 13. Well, look, this also applies to here. That's not a point of inflection, but that intersection there, if I move 13 to the right, so look, negative 0.508. If I move 13 to the right, that's going to put me right here at 12.492. That makes sense? So it makes sense that it's going to repeat again. So this intersection at 8.508, because I know that this repeats every 13, I'm going to have another intersection if I move 13 to the right at 21.508. Cool or not cool? Cool. So I hope that you guys are starting to understand the concept that it's core, and I hope that you guys are not becoming robots. All right, now I'm going to go really slow right here, really slow. So those are the answers. There it is. All we did was push some buttons on Desmos. If you have a calculator, it would be the same thing. You push some buttons, and you just tell the calculator to give you the intersections. So how do we do it algebraically? Okay, so here we go, guys. I'm going to go slow. I'm just rewriting the whole statement. 7 cosine 2 pi over 13, x minus 4, close, close, plus 9 equals 5. All I did was rewrite the statement, so that's all I did, guys. So when I mean find it algebraically, that means I want to solve for x, just like you've been doing all this time, all your life, when you've been in junior high. So since I want to solve for x, the very first thing I got to do is I got to get rid of that 9. How do I get rid of that 9 there? Subtract. Perfect. So let's just subtract it. Minus 9, minus 9. So I'm going to have 7 cosine 2 pi over 13, x minus 4, close, close, equals, the difference between 5 and 9 is 4. The 9 is larger, so negative 4. Are we still okay, guys? All right, now, I need to get rid of that 7 in front of the cosine. So how do I get rid of that 7 in front of the cosine? Perfect. Divide, divide. If you want to say multiply by reciprocal, that's fine as well. Cosine 2 pi over 13, x minus 4, close, close, equals a negative 4/7. And don't worry, guys, I'm giving you guys time to catch up and write everything. Rubio, you there? All right. Next, I want to get rid of the cosine, guys. So I want to get rid of the cosine on the left-hand side. the only way to get rid of the cosine on the left-hand side is to do the inverse cosine. So hopefully you understand that from doing inverses in your algebra days. But the only way to get rid of that trig there, the only way to get rid of cosine there is to do the inverse of it. So, and hopefully you know that from just like finding angles and stuff like that. So I'm gonna get rid of cosine by doing the inverse. So here we go. 2 pi over 13, x minus 4, close. And you no longer need two parentheses because that's all you have there now, equals. And instead of just writing arc cosine, I'm gonna put plus minus arc cosine of whatever you have on the inside, 4/7, plus 2 pi n. Chavez, what are you doing? What are you doing? Hold on. All I did, guys, relax. All I did was this. All I did was this part right there. So let me go back so you guys can see. You already wrote this part down, Rubio? Okay. Well, you're fast, miss. All right. You can distribute 2 pi over 13 if you want to, but nah, let's not. So now, what do I got to do? I got to get rid of the 2 pi over 13. I could either say divide by 2 pi over 13, but usually when you have a fraction, you don't want to have a fraction within a fraction. So I like to say multiply by the reciprocal. Whatever you do to one side, you do to the other. So I'm going to multiply all of this by 13 over 2 pi. Whatever you do to one side, you do to the other, 13 over 2 pi. So here we go. I'm now going to have x minus 4 equals, and we're going to put this right in the front. So I'm going to write plus minus 13 over 2 pi arc cosine of negative 4/7. And we'll find out what that is in a decimal in a little bit. Plus 13 over 2 pi times 2 pi, I get 13n. And that should not shock you. That is your period, guys. That 13n should not shock you. So hopefully you're seeing all these pieces come together. Last but not least, I need them. What do I got to do to get the x by itself? And I see some of y'all still writing, so I'm going to slow down. Let me slow down.
Add 4.
Add 4. So here we go. Do not, okay, don't write this down, just listen, guys. I'm going to help you guys. A long time ago, when I was a rookie teacher and I was teaching this, I pretty much teach it more or less the same, but when I first started, I would just say add 4, and everyone got it while I was teaching it, but then when they started doing the assignments, they were getting them wrong all the time. And it was because they had a habit of writing plus 4 at the end, and they were messing up with the number big time, like all over the place. So to not mess up, and you'll never mess up. I did this one correction, and after this one correction, 100% got it right all the time. So we never mess up. Write the 4 in the very front. 4 plus minus 13 over 2 pi, our cosine, negative 4/7 plus 13n. Okay, go ahead and write it, guys. And I'll let you guys know to see if that makes sense. Does that make sense? Why I put the 4 in the front? Because if you put it in the back, you're going to make a mistake with the 13 there. Because that's an N, not a... All right. Here we go. Oh, what's up, Ruby? You had a question?
No.
Okay. Sorry, miss. All right, here we go. I have two expressions. I have one plus and I have one minus. I'm going to tell my calculator to give me both. I'm going to go to Desmos. So you guys are going to tell me this part right here. Well, you don't have to. I think I can remember, but just in case. So here we go. I'm going to Desmos. And I'm just going to click back because I don't want a graphing calculator. I want a scientific. So here we go. I'm going to write 4 plus, what was it, 13 over 2 pi? 13 over 2 pi. And then I had arc cosine. And what did I have on the inside? Negative 4 over 7. Oh, I'm in degree mode. I need to be in radian. Boom. 8.508. So 8.508. So I'm going to go back. I'm going to go back. And I'm going to write 8.508 plus 13n. This is what you call a general expression. I'm going to write x2 here on the side. x2 equals, Instead of adding, what do you think I'm going to do? Subtracting, because it says plus minus. So here I am going back to Desmos. And instead of that plus, all I'm going to do is remove that plus and put a what? Yeah, minus. Hey, no more yawns. The next one's a demerit. So negative 0.508. Oh, you think I'm joking? I'm going to write you on. No, I'm kidding, miss. I'm 100% joking. And if I were to write one up, it would be a fake demerit. It wouldn't be a real one. What did I just say? Negative, what did it say? Negative 0.508. And there it is, guys. So now, from there, so x equals, and I can already see that I'm going to be missing one, huh? Yeah, so it gives me this one first and then that one second. So it's gonna not give me those. I'll show you how to get that one, guys. So the first one that I get, I'm gonna leave some space. The first one that I get is this one, negative 0.508. The next one that I get, this is coming from x2, so the second equation. The next one I get is that one, 8.508. 8.508. That's coming from equation 1. The next one is coming from equation 2, just add 13. So I got my little calculator here on the side, negative 0.508 plus 13, and I get 12.492. And then the next one's going to come from equation 1, so 8.508 plus 13, that's 21.508. And the next one is the 12, so I'm going to scroll up, push enter, plus 13, and I get 25.492. And I believe that is it, because if I keep going more, I will be outside the domain, outside of this guy. All right, so I'm missing one. You don't know that you even have one to begin with, unless you did the graphing part, but you do know the period. So if they tell you the domain is between negative 7 and 27, in your head you should be like, huh, well, I haven't gone all the way to negative 7 yet. If I take this one right here and I subtract 13, will I still be between negative 7 and 27? Well, obviously 27, but will I still be to the right of negative 7? Yes, you will. So take that 8.508 and subtract the 13. So 8.508, and I'm going to go minus 13, and you get negative 4.492. Minus 13 to get that one. How do we feel, guys?
Good.
All right, let's all come back.